All right, we are continuing on page 12, looking at adding and subtracting whole numbers and perimeter. And really what we're going to be looking at in here are some properties of addition and then the corresponding properties of multiplication in the following section. So just a few reminders. A variable is a symbol, usually a letter. That is used to represent an unknown number. Addends is the term for the numbers that you're adding together. And then sum is the answer to an addition problem. Now with our properties, let's put this up here a little bit. Okay, so the two main properties of addition are that it is commutative and associative. So commutative meaning that we can change the order of the letters. So A plus B is the same as B plus A. In terms of more specific numbers, it means that 5 plus 12 is going to be the same as 12 plus 5. Order is not important. It can be flipped or switched, however you want to talk about that. And think about it this way. Commute is the root word there. So that means movement. So the numbers move. The numbers move in the commutative property. But it does not change the answer. And that's also going to be true for multiplication, which we'll discuss in a little bit further on. The associative property is going to be how things, associations or groupings get changed. So you'll notice that the numbers don't move. We've got ABC and ABC, but in this, on the left-hand side, we have the A and the B grouped together first to be added together, and then we add C. But on the right side, we add the B and C together first, because they're in the parentheses, and then we continue by adding A. So if I wanted to make the two sides match that, the parentheses move, but not the numbers. I'm just going to stick the 1, 2, and 3 in there, but instead of having the 1 and 2 grouped together first, I'm going to group together the 2 and the 3. So the parentheses are moving there, but not the numbers. So how they are grouped, the associations change. Right, flipping over to page 13. Whenever you see an identity property, identity is going to refer to the fact that it stays the same, or we stay at the same value. In this case, it's going to be A. So identity, whoops, sorry, you can see that. There we go. It's going to be that we stay at the same value. So if I add 0 to A, I stay at A. If I add 0 to 5, I stay at 5. So any number plus 0 is that same number. And that is why we call 0 the additive identity. So it is the thing that we can add to any number that keeps it the same. So adding 0 keeps it the same. Identity of the number stays the same. Additive. Let's see. There we go. Okay. Difference. A reminder that that is the answer to a subtraction problem. And a reminder for when we look at some of the more real life type problems that if they are talking about perimeter, you're going to walk around the figure. So we're just going to add up all the sides and that will be the perimeter. Occasionally, they will try to trip you up by putting things in different units. For example, some of it in meters and some of it in centimeters. So make sure that all your units are the same first. It's just do a quick check with that. It usually is going to be fine, but want to make sure you're not getting thrown off based on that. All right, some We'll look at some examples of these guys, of these different properties. And then we will talk about how they are related in multiplication. And then that will be the end of our videos for the day here. Okay, so I'll do the first one on each of these, and then I'm going to pause the camera and have you guys have a chance to try out the other exercises and then compare to what I have and see if you're on the right track. So the right side of the addition problem using the commutative property of addition. Okay, so commutative property, to use that means I'm commuting my numbers, so I'm going to move the numbers. So instead of having 101 plus 44, I'm going to reverse that, and I'm going to have 44 plus 101. That would be the correct other side of the equation. Okay, rewriting this addition problem with the associative property by inserting a pair of parentheses. So on the left and on the right, we've got 23, then 9, then 10, so that's all good. On the left, we have the 23 and the 9 associated or grouped together first. So I want to group the other pair of numbers. I'm going to group together the 9 and the 10. So that would be the pair of parentheses that I would insert there to get that correct. And then the addition property of 0. So I'm not going to do the explanation part. I'll have you try to come up with a sentence for that. How would you explain the addition property of 0 to somebody who's not in our math class? And then we'll simplify these couple of expressions. So I'll give you a little blurb on this once I come back from pausing the camera. But looking at the first one there, 423 plus 0 is going to be 423. And I'm going to do the last one because I did not get the bar in there for the adding to make it look a little bit nicer. So when I am adding 67 and 0 in a vertical way, then I would still just end up with 67. Okay, so I am going to pause this, give you guys a minute to try these yourself, and then when we come back, I'll have mine written in and I will talk about them briefly. Okay, coming back to the commutative property of addition first. So for the second one, so we would flip it to y plus x instead of x plus y. In the second example of the associative property, instead of having the parentheses associating the last two items, we're going to have it associate the first two items, the r and the s. And then these middle ones here, when I'm adding 0 to different numbers or variables, I just end up with that thing that I started with. So 0 plus 25 is 25. 0 plus x is x. So a way to explain the addition property of 0 would be that adding 0 doesn't change the value we started with. It stays the same. Something like that. Right? Because, you can think about it as 0 makes no change. There's 0 change happening here when we add 0. All right. I'm going to pause for another moment until I can get my pages flipped over. Okay, we are here at the top of page 14, and I am going to leave this one for you guys to do and see if you can put that in your own words so that it will help you to remember it. I've told you how I think about it, so you need to figure out how to attach that to your learning that you already have so that it sticks in your long-term memory. So we'll come back to that on a different day. All right, the next section we are looking at are those same two properties, commutative property and the associative property, but now for multiplication. So still the same essential quality that we are flipping those values. We can switch the order. So I'm going to change this to 3 times 4 instead of 4 times 3. Still both equal to 12. So let me make that a little bit more obvious. There is a multiplication symbol. And yeah, so we can switch or or flip. Whatever word you like better. For that order can be switched or flipped for commutative. With the associative property, notice again, we still have those three numbers in the same order, but instead, 8 there, and 2 and 5 still go in the same order, but instead of grouping together the first two, we're going to group together the second two values. So we move those parentheses. And similar to 0, we have an item that when we multiply by it, we don't change our number. And that is going to be the multiplicative property of 1, which is also called the multiplicative identity property. And it's just, I personally think it's really fun to say multiplicative, so I like to say that a lot. So practice saying it out loud. It's a good thing. All right, so A times 1 is A. So multiplying by 1 doesn't change it. So if I have 7 times 1, that's going to be 7. So any number multiplied by 1 is that same number. That's why 1 is the multiplicative identity. All right, so fun to say, maybe not as fun to try to spell. And then we have one other thing here, because 0 does, remember 1 and 0, they always have to be different. 0 has a special property when we are looking at multiplication versus when we're looking at addition. So we do have that thing that's called the multiplicative property of 0. You also might see it as the 0 factor law. And remember, factor is one of those words that should make you think of multiplication. So that's why it's another way to talk about that. And when we are multiplying those things, we just get 0. So if 0 is one of the factors, we end up with 0 as our answer. Any number multiplied by 0 is 0. I'm going to pause once more so I can get that flipped over. And we'll move on to 15 and 16, and that'll be our last bit here. I might have to, I'm going to have to go into one more video here. The last property that we're looking at is the distributive property of multiplication over addition. And so this is where we're combining those two. And essentially it means that we're going to multiply what's on the outside of the parentheses by each thing inside the parentheses. So multiplying A by each thing inside the parentheses. And often what will happen is in further situations in math, we won't be able to add these two numbers together. So the only way to get rid of the parentheses is to use the distributive property. So we are going to multiply the 5 by each thing here. So we get 5 times the 10 and 5 times the 2, which is going to give us 50 plus 10, or 60, which would be the same as if we were doing the addition inside the parentheses and following our usual order of operations. So if we looked at our usual order of operations, we would do those parentheses first. So we have 5 times 12, which would be 60. So it does work. Mainly, like I said, we're going to use it when we can't actually add these two numbers together and get a single term. So 10 and 2 we can add together and get to 12, but if this was x and 2, then we couldn't get it to a single term, and we would have to use the distributive property to clear those parentheses. And we'll talk about that as we go further on in solving different equations and simplifying some expressions. And last thing here is area is going to be kind of like the perimeter as far as multiplication goes. So here we are covering things. So we want to shade it all in. So our length times our width would get what I need to shade that. And please remember that your units need to be the same before you use the formula length times width. And this one is a square, so they're the same.